We're talking about um, basic electronics. Basic electronics. Okay. So for the basic electronics, it all deals with the electrical components or the component in an electrical circuit. So we have the capacitor. We also have the battery and other components in the electrical circuit. So we'll be starting with the nature of atom. So everything in the universe is made up of atoms. Yes, everything in the universe, the sun, the stone, everything is made up of atoms. And you say that atoms are the smallest unit of matter. So they are the smallest unit. Yes. So everything in the universe is made up of atoms. And we also know that it consists of the protons, the neutrons, and the electrons. So let's say we have this. So everything in the universe consists of the atom, and we have the nature of the atom like this. So we have these things located on the shell of the atom. They're located on the shell of the atom. So these are called the electrons. Yes. Also, this is called the neutron. The neutron particularly contains, sorry, the nucleus. Let me make nucleus. So the nucleus, which contains the neutrons and the protons. Neutrons and protons. And we have the shell. So the one in which the electrons are located on, they are called shell. So we have the shell, the electrons, the nucleus, which contain the neutrons and the protons. Yes. So atoms in different elements differ in their number constituents, which account to their difference in characteristics. Yes. So different atoms have different number of constituents. So let's say I have carbon atom, which is element 6 6. It has different proton, it has different electron, it has different neutron as compared to, let's say, aluminium. Yes. So every element has their own constituent. They have their own different constituent. They are not the same. Additionally, let's say for the nature of atom, we can conclude that the mass of every atom is equal to, that is the electron of one atom, is equal to 9.11 by 10 to the power negative 31 kilogram. Yes. And also the charge. So mass of electron and also the charge is equal to, as a negative charge is equal to 1.602 by 10 to the power negative 19 coulomb. So that's it. The mass of electron 9.11 by 10 to the power negative 31 kilogram, and the negative charge is 1.602 by 10 to the power negative 19 coulomb. The same thing applies to proton. So the mass of proton is equal to 1.673 by 10 to the power negative 27 kilogram. So for this one, the mass of the proton, they have the same, the charge of the proton, the neutron, the electrons are the same, but such that they are in opposite direction. So if proton will be positive, therefore the electron will be negative. So the same thing applies to the charge of proton. So the charge of proton will be the same thing, such that if the charge of proton will be the same as the charge of the electron, such that if proton is positive, the electron will be negative charge. Also, the mass of the neutron is also approximately the same as that of the proton. Yes, so if you want to get the mass of neutron, is approximately equal to, or approximately the same as mass of proton. So something like that. So that's how the electrons, the protons, and the neutrons are arranged, or their constituents are being formed, or let's say they want to get their masses. That's how to determine their masses, and these are fixed masses of them. So we will start with the nature of the atom as we are continuing. So the nature of the atom particularly. So we know that, so from this we know that we've learned that um every element or atom has its own constituents. So let's get back to ways of finding, let's say, the mass numbers, the neutron numbers, and the proton numbers of elements. So let's say we have, let me draw the periodic table. Let me draw the first 20 elements. This is the first 20 elements particularly. So let me helium, lithium. So hydrogen. So let's say hydrogen will be cleared. The hydrogen, we don't know where to place it. Either to be at the first group, or the seventh group. So that the hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Wait, hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've made it 9. I have to make it 8. Let me clear one from it. Let me clear one from it. Let me clear one from it. Let me clear one. Where is it? Let me clear this part. Let me clear that part. Um, okay. So let's continue. So let's say, let me make it like this. Okay. Helium, lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, neon. So sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So I'm drawing the first 20 elements for now, so that it will help us. So let's say we have something like this, the first 20 elements here. So for this one, each element here or each atom here has its own constituent. So let's say chlorine. Chlorine has its own atom. So chlorine has atomic number of, for here it will be 17 and a mass number of 35. So for this element here, we can say that the mass number of this atom, mass number, is the superscript. So the superscript, that is the 35 here, will be the mass number, so which is equal to 35. Also, the atomic number for this element will be the subscript, atomic number is the 17. So the atomic number is the same as the proton number, as the proton. And also, if you want to get the neutron number or the neutron will be equal to the electron plus proton. So for this one too, the electron will be equal to the proton number. The electron is the same as the proton number here. So here you can say that the electron and the proton numbers are the same. So the neutron will be 30. Sorry. Yeah. So for us to get the neutron, let me verify something here first. For us to get the neutron is not the same as the neutron will be equal to the mass number. Let me make it well. Mass number minus the electron. Let me make it proton. Mass number minus proton. So if you want to get the neutron number will be equal to mass number minus the proton, because the mass number will be equal to the neutron plus the proton. So if you want to get the neutron, then it will be mass number minus proton. So the mass number was 35, the proton was 17, this equals 18. So the neutron number is equal to the mass number minus the proton, and the electron and the proton will be the same, something like that. So that's how to identify or to find um, the number of electrons, protons in a particular atom or element. Also, as we drew the electronic configuration like this. Number of electrons in an orbit is given by 2n squared. So that means that for the first shell, we have n equals 1, which is equal to 2 times 1 squared, making 2. So we have the number of electrons in an orbit will be equal to 2 for the first shell, for the first orbit. And we get to the second orbit, let's say n equals 2, we get 8, then it moves on. N equals 3, it implies that you have 2 times 3 squared, making 18. Then it moves on and on and on and on. So that's how to determine the number of electrons in an orbit. So number of electrons in an orbit is equal to the 2n squared, something like that. Yeah. So that's how to identify the number of electrons in an orbit. And also from the periodic for this particular topic or the basic electronics, we are much concerned about the semi-metals or the elements which are acting as semiconductors. So for the table, we have metals, the semi-metals. We also have the non-metals, and also we have the lanthanides and actinides. So we are much concerned about the semi-metals one. That are the semiconductors we normally call. Also, elemental semiconductors, they are formed from group 4 of the periodic table. So if you draw the periodic table, they are mostly formed from that. And also, if you want to get the compound semi-metals, so elemental semi-metals, semiconductors, let me make it like that. Semiconductors, they are formed from group 4, elemental one. And let's say we have the compound semi-metals. The compound semi-metals are formed from the combination semiconductors or semi-metals. That one, it involves the combination of the group 2 element and the group 6 element, or the group 3 element and the group 5 element. So group 2 or 6. And okay, let me make it like this: group 2 and group 6, or group 3 and group 5. Yeah. So these are what we normally use to find the compound semiconductors. So they aid us in 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 analyzing the semiconductors. So if you use a periodic table, you can analyze or get the chemical properties of many elements there. So we'll get to the bonding models of atoms. The bonding models of atoms. So how atoms or elements are bonded to each other, or how we get bonds between atoms or elements in a compound. Yes. So atoms bond. So covalent bond model. So atoms bond together in either they are amorphous, they are polymorphous, polycrystalline, or single crystal structure. So either they are amorphous, polycrystalline, or single crystal structure. So you say something is amorphous, it means that it has no form, like they are disordered, disordering structures. So their structures are disordered. And also, so this one is disordered. For polycrystalline, it means that it contains a lot of crystals. So small crystals being combined together to form very huge crystals. They are called the polycrystalline form of the covalent bond model. And also have the single crystal structure. The single crystal structure consists of one large crystal with regular shape. So the single crystal structure, it contains a very large crystal. Yes, so let's say only one. That one is only one, and it has a regular shape. So like this, something like the box I've drawn, just a crystal. So semiconductors, they have four valence electrons, because for if it has four valence electrons, mean that it can easily lose or it can easily gain. Because if you have four, you don't know where to go. Either you are losing or you are gaining. So that aid them in forming bonds. Like that makes us consider them to be semiconductors. So let's consider silicon like this. Silicon like this. For this one, we don't know either it is losing or it's gaining electrons. Yes, because silicon is it has four valence electrons. When you say valence electrons, Valence electrons are the electrons located at the outermost shell of the atom. So the electrons out in the outermost shell is called the valence electrons. So silicon has 4 valence electrons, hence it is considered as a semiconductor. The same thing applies to boron and other semiconductors. So now we will take into consideration our crystal lattice structure. So we talk about the covalent bonding model. So I also get to the crystal lattice structure. So the crystal lattice structure of solid state metals. So maybe they are solid. So the solid there are some structures in it. They are latticed. They are regular patterns. So let's say I have something like this. So this for this solid for this solid they there's a bond between their solids. So there is lattice existing between these solids. So the crystals or the solids being here are now in the lattice structure form. So they are in the solid state material. Yes. So there's a bond existing between these solids there, these solids there, these solids, and it is a regular shape. Yeah. So that's how the solid lattice mean. So we also get to covalent bonding. So covalent bonding for covalent bond, if you say covalent bond, mean that there's um the sharing of electrons. So let's say we have coffee, or let's say we have food, we have apple here, and we say that Emma and John, they have to share this apple. They have to eat this apple. So both of them have to share the apple. One cannot take it. So as they are sharing, they are forming a covalent bond. So a covalent bond existing between atoms or compounds involves sharing of the electrons. They are sharing their electrons. They are sharing their electrons so that they can become more conductive. Yes. So as they are sharing, then they fill their outermost electrons fully to achieve the octet or the duplet structure. So that's how to identify the covalent bond model. So in this video, we talked about the nature of the atom and also the covalent bond model. Thank you.